Now here we have 5 minus 2x times 5 plus 2x. And this is going to end up being a difference of squares because these binomials are identical except for the operation. We have a minus and a plus. So when we multiply the first terms, we get 25. We multiply the outside terms. 5 times 2x is plus 10x. And then inside terms, the negative 2x times 5 is negative 10x. And we multiply our outside terms, or last time's terms, sorry. Negative 2x times positive 2x is negative 4x squared. Now when we combine our like terms, 10x minus 10x is going to be 0. So there will be no x term in our solution. So we end up with 25 minus 4x squared. And again, this is a difference of squares because we have two terms that are being subtracted, and one term being subtracted from another, and 25 is a perfect square of 5, and 4x squared is a perfect square of 2x. And so this is the special case known as a difference of squares. X minus y times x plus y. Multiply the first terms. X times x is x squared. Multiply the outside terms. X times y is xy plus xy. When you multiply negative y times x, that's going to be negative xy, and we list the terms in the variables in alphabetical order, so we should put the x before the y. That way we can identify that this is the same term. These two are the same terms. And then we multiply the last terms, so negative y times positive y is negative y squared. And then again, xy minus xy is going to be 0, so this simplifies to be x squared minus y squared, and again, this is a difference of squares. And you can predict this by looking at the question. That again, we have two identical binomials except for the operation between them. X plus 3y is 3y squared could be written as x plus 3y times x plus 3y. We multiply the first terms. X times x is x squared. Multiply the outside terms. X times 3y. Again, make sure you put your variables in alphabetical order. So it's going to be plus 3xy. And multiply our inside terms. 3y times x. Okay. We want to write that as plus 3xy. And multiply our last terms. 3y times 3y is 9y squared. And so now we can combine our like terms, and 3xy times 3 plus 3xy is 6xy. Remember, we just add the coefficients, the variables, and the exponents stay the same. So again, this is a perfect square trinomial because if we take the square root of 6, then that's going to be 3. And if we square it, we end up with 9.